Hey, AP Calc, I just want to make this quick video to kind of go over all the things that you can expect to see on tomorrow's test on integrals. So just launch right into it. Topics. Obviously, you can expect to see antiderivatives. Know how to take the integral when it's indefinite. And definite. So indefinite, if you remember, you have to make sure you put plus c, and that's whenever you aren't given the upper and lower bounds, or the left and right bounds of your integral. All right, let's talk about some methods. So methods of integrating. First and foremost, the one that we've done most recently is u substitution. Another one is separating. So like if you have like cosine of x plus x squared, you can separate those into two individual function or two individual integrals because they're separated by a plus sign. Distributing. All right, so if you have something like the integral of x squared plus 2 squared dx, just simply distribute x squared plus 2, and you're going to get one long polynomial that you'll be able to easily integrate. The next thing is trig, so make sure that you have all of your integrals of the trig functions memorized. And the signs, right? It's important to know the signs. Power rule. Power rule is just simply, if we're talking about the integral of x squared dx, this is equal to x cubed divided by 3 plus c. So that's just using the power rule. And then make sure you know how to take the integral of an absolute value function. All right, so remember, with an absolute value function, it's almost like you have to split it up into two individual integrals, one for the section on the left. So here with me. So like one for this section and one for this section. Okay. The next topic, make sure that you understand integral properties. So what do I mean by that? Well, make sure you know how to split integrals when it comes to their upper and lower bounds. So splitting integrals. And an example of this would be, let's say that we have an integral from -2 to 3 of f of x dx, and we're adding the integral from 3 to 5 of f of x dx. This is the same as the integral from -2 to 5 of f of x dx. All right, make sure that you know that the integral is the area under the graph. Oops. Area under the graph. And then make sure you know just generic properties like, let's see, I'm thinking of one right now. If I give you the integral from a to b of f of x dx, know that that's equal to the negative integral from b to a of f of x dx. So when we swap a and b, then we have to make sure that that becomes a negative integral. Okay, so those general things. Make sure you know Riemann sums. Whether I give you a graph or a table, know how to find the Riemann sums in regards to the trapezoidal rule, the right Riemann sums, or the left Riemann sums. Know the difference between displacement versus total distance. Displacement versus total distance. So displacement would just be like, you know, you have your v of t equation, which we'll call f of x, and you just take the integral of it. However, total distance is the total distance traveled, so we have to take the absolute value of f of x. All right, so definitely make sure you know the difference between displacement and total distance. The next thing is the fundamental theorem of calculus. This is pretty straightforward. It's just when you have an integral from a to b of some function, we'll say f prime of dx, that's just equal to, you know, you find your integral and we just say f of b minus f of a. We've done this countless times in class. Pretty straightforward for the fundamental theorem of calculus. The second fundamental theorem of calculus is another important one. The second fundamental theorem of calculus. The second fundamental theorem of calculus states that if you are taking the derivative of an integral from u to v of f of t dt, that's just going to be equal to f of v prime, times v prime, I should say, minus f of u times u prime. All right, I'm going to give you an example of this. We actually did this one in class. So that the example we did in class, we said, all right, we're taking the derivative of the integral from pi over 2 to x cubed of cosine of t dt. And we said that that was equal to cosine, so remember, v of t, or I'm sorry, f of v, which is just cosine of x cubed, and then we multiply that by v prime. V in this case is x cubed. The integral of x cubed is 3x squared. And then we subtract f of u times u prime. But since f of u, or I'm sorry, since u is a constant, the derivative of that constant, which is pi over 2 in this case, is 0. So we just subtract 0. And what we get is 3x squared times cosine of x cubed as our answer. All right, we've done several examples like this in class. Another common one that we do is when we just say like d dx of the integral from, we typically just say some constant, right? So I'm going to say 2 to x of t squared plus 1 dt. This is just equal to x squared plus 1. That's it. Because we are, we're plugging in x for t, and then we multiply by the derivative of x, which is just equal to 1. So this is our final answer. All right, so that's the fundamental theorem of calculus. The next thing I want to make sure you know, and definitely make sure you remember this equation, is the average value of f of x. All right, As long as you remember this, it's very easy. Just don't forget it. 1 over b minus a over a to b of f of x dx. That's it. All right. Also remember that if we're talking about position, velocity, and acceleration, the derivative will go from position down to velocity. So the derivative of position is velocity, and the derivative of velocity is acceleration. And the antiderivative, or the integral, will take us in the other direction. All right. And then last but not least, graphs and tables. So if I give you a graph, I could give you a question where, like, here is the graph of f of x. What is the graph of, which one of these is the graph of f prime of x? Or the other way around, right? Here's the graph of f prime of x. Which one is the graph of f of x? So we're talking about derivatives. Derivatives and integrals. Derivatives and integrals. All right. So these are the topics that you can expect to see on your test. Make sure you study, do those review problems that I posted to yesterday's post. And as always, if you have any questions, please either email me today or come see me 3rd or 4th period tomorrow. All right, and have a great rest of your day, and I'll see you all tomorrow.